This isn't going to cooperate. There we go. So cosecant of x times the sine of x is equal to 1 because we know they are reciprocals, right? A number times its reciprocal is going to be equal to 1. So alternative form for that first set of identities would be cosecant of x times the sine of x equals 1. So then think about that next set. What that's telling us is that we could think of this as cosine of x times the secant of x, and that is equal to 1. So I would suggest you write that in also on your reference sheet. And then the last one there is this tangent x times the cotangent of x, and that is equal to 1. So those are just the various forms of those reciprocal identities, kind of in what, like I said, what I would refer to as like an alternative form of them. Okay? All right, let's look at the quotient identities and how we could rewrite those kind of using some alternative forms also as well. If you look, like, you know your reciprocal identities already. Quotient identities, you may or may not remember them in this format, but you definitely have memorized. You know that tangent is y over x. You've thought of it that way. Now you just have to make the connection with the fact that y is equivalent to the sine and x is equivalent to the cosine. So tangent is the sine of x over the cosine of x. And for cotangent, the cotangent of x is going to be the cosine of x over the sine of x. But let's look at some alternative forms for these. If we solve and just get the sine by itself, in other words, let's multiply both sides by cosine, then we get that the tangent of x times the cosine of x is equal to the sine of x. So that's kind of an alternative form for that quotient identity. And then along those same lines, if we just focus our attention on this, if we were to solve this for cosine, think about what we would do. If we wanted cosine by itself, we would divide by that tangent, so we would have sine of x over the tangent of x. So there's two alternative forms for this tangent identity, this tangent quotient identity. And then let's consider our cotangent also and how we could write alternative forms for that. So we could multiply by the sine that was in the denominator, so we could have cotangent of x times the sine of x equals cosine of x. That would be one alternative form. And then the other one, think about how we could simplify this if we wanted just this sine x by itself. So then it would be sine x is equal to cosine x over cotangent x. So those are just alternative forms for these quotient identities, right? Okay, the last ones, these Pythagorean identities, these are the ones that we've got to spend a little bit more time trying to get them memorized, just because they're new, right? They are referred to as the Pythagorean identities because they are derived from the Pythagorean theorem. So if you are curious about how these equations how these identities come about, come talk to me and I'll show you how you can derive them from what we know about Pythagorean theorem. But otherwise, I'm just going to tell you, get these memorized, right? All right, questions or comments so far before we look at these Pythagorean identities? Okay, so that first one here, Andrew, could you read that first one for me?
Sine squared x plus cosine x equals 1.
Okay, do me a favor, read that again.
Oh, sine squared x plus cosine squared x equals 1.
Okay, so, and then please keep in mind, it could be sine squared x plus cosine squared x equals 1. We might have theta in there, we might have alpha or beta, that type of thing, but sine squared x plus cosine squared x equals 1, okay? We're going to use that identity quite a bit, so I'm going to ask you to kind of keep repeating that over and over and over again, just to kind of help us with that process of getting these memorized. So Andrew, can you read that one more time for me? Great. Okay. So let's look at some alternative forms for this identity. So that's sine squared x plus cosine squared x equals 1. We could solve for just the sine squared. In other words, we could keep this on the one side and we could move that cosine squared over to the other side. So an alternative form for this could be sine squared x equals 1 minus cosine squared x. Right? That would be one alternative form. Now the other way we could think about this is we could get the cosine squared by itself and we could move the sine squared over. So that means we would have cosine squared x equals 1 minus sine squared x. Thank you for waiting. Okay. Is that working? All right, Andrew, what is that again? Can you read that one more time?
The last one?
Yeah, the first one.
Oh, sine squared x plus cosine squared x equals 1.
Sine squared x plus cosine squared x equals 1. Any psych students in here or former psych students? Oh, good. Okay, put you on the spot here, Drew. Studies, research shows that if you hear something repeated, how many times that it sticks in the memory banks?
I want to say like 5 seconds.
Wait, how many times?
How many times?
How many times?
Uh,
Dude, I don't know. For the last year.
7. My lucky number. You're going to hear these identities repeated a lot more than 7 times, but it's to help you get these memorized. All right, Drew, what's the second identity? Can you read that one for me, please?
1 plus tan squared x equals secant 2x.
Okay, say that again.
1 plus tan squared x equals secant 2x.
Secant
Yeah.
squared x, right?
Yeah,
Okay, so 1 plus tangent squared x equals secant squared x.
Yeah.
All right, let's think about alternative forms for this one. We could keep this 1 by itself and move the tan squared over to the other side. So we could say that 1 is equal to secant squared x minus tangent squared x. We could also keep that tangent squared by itself. So tangent squared, and then we would have to move the 1 over to the other side. So tangent squared x is equal to secant squared x minus 1. So those are 2 alternative forms for Drew's identity, which says what, Drew?
1 plus tan squared x equals secant squared x.
Okay, that sounds better. Okay, Andrew, what does yours say?
Sine squared x plus cosine squared x equals 1.
And you still had to look on your paper. You will have it memorized by the end of the class period. I can promise you that. Okay, so here's the beauty of this identity and then the next identity. Because if you listen to Drew's identity, which says what, Drew?
1 plus tan squared x equals secant squared x.
Great, thank you. And said with conviction, loudly and clearly. I love it. Okay, and then, I'm sorry, one more time?
Should we repeat it?
Yes, please.
1 plus tan squared x equals secant squared x.
Okay, now think about that one. And now listen, Nicholson, can you repeat the last one? Read the last one for us.
1 plus cotangent squared x equals cosecant squared x.
Okay, there's a connection there. They are very close to the same thing. So if you can remember Drew's, which says what, Drew?
1 plus tan squared x equals cosecant squared x.
Time out, rewind, erase that. Say that right for us, please.
1 plus tan squared x equals cosecant. Not cosecant. Oh my god, bro.
Bro is right. Okay, you got this.
I don't.
You do. Read
I
it.
don't.
Read it.
Alright, 1 plus tan squared x equals secant squared x.
There you go. Beautiful. Yes. 1 plus tangent squared x equals secant squared x. Now think about Nicholson's, which says
1 plus cotangent squared x equals cosecant
Okay, what do you notice that is so similar to Drew's and Nicholson's identities here? Okay, 1 plus tangent squared in the first one in Drew's, 1 plus cotangent squared in Nicholson's, equals secant squared equals cosecant squared. Those are co-functions, right? It's 1 plus tangent squared equals secant squared. If you can remember that, then you just have to remember to add the cos to get Nicholson's. 1 plus cotangent squared x equals cosecant squared x. Or you can remember Nicholson's, 1 plus cotangent squared x equals cosecant squared x, and then get rid of the cos. So 1 plus tangent squared x equals secant squared x. Okay, let's think alternative forms for this, for Nicholson. So we could get the 1 by itself. So then we would say 1 is equal to cosecant squared x minus cotangent squared x. Or if we want the cotangent squared x by itself, we're going to have cosecant squared x minus 1. All right, Drew, keep working on that. By the end of the class period, you're going to have it. Andrew, what was yours?
Sine squared x plus cosine squared x equals 1.
You've got it. And he didn't look this time. See, he's got it. Okay, Drew,
Let me read it again.
please.
All right, 1 plus tan squared x equals secant squared x.
Beautiful. See, you've got it. Okay, Nicholson, do you have yours?
1 plus cotangent squared x equals cosecant squared x.
There you go. Beautiful. Okay, there's our identities. Keep working on getting those memorized. The sooner you get those memorized, the easier your life will be for the next couple of weeks, I promise. All right, let's review some basic math skills that we're going to need. So this is in the bottom of your notes packet, if you haven't pulled that out yet. And let's take a look. How do we, if we've got 3/5 plus 1, what are we going to do there? What do we have to do with this? Uh-oh, guys.
What? 1 and 3/5.
Okay, you're right, 1 and 3/5, but how are we going to, we want to combine that together and
8/5.
how do we know it's 8/5? What are we going to, how are we going to rewrite that 1?
5 over 5.
We're going to rewrite that 1 as 5 over 5. We know 5 over 5 is equivalent. That way we have our common denominator and we can get our 8/5. So yes, you are right, it was 1 and 3/5, but I wanted to think improper fraction. Squaring fractions. We just square the numerator, square the denominator. So 4 squared is 16, 7 squared is 49. All right, if we are adding and we do not have common denominator there, that's the first thing, is that we have to get common denominator. So someone in my other class was saying, well, you cross multiply. Well, it's not exactly cross multiplying, but you, like, the 9 is what you multiply by over here. The 7 is what you multiply by over here, right? So we get 18 over 63 plus 35 over 63, and that gives us 53 over 63. All right. And the square root of 16 over 25, we just take the square root of 16. We know that's 4. Square root of 25 is 5. This one's a little more involved. We know the square root of 4 is 2, but then we get 2 over root 5. And so we've got to rationalize, right? Can't have radical in the denominator.
Can you go back to 5 real quick? I just forgot what you said.
Sure. Square root of 16 gives us the 4. Square root of 25 gives us the 5. Right? Okay. And then for 6, we have to rationalize, multiply by the square root of 5 over the square root of 5. Sorry, that is really messy looking. Did I miss one? Did I skip one? I did. Shame on me. Sorry about that. Thank you. Okay.
That's because 5. That's because 5 on top.
Yeah, we just get a 5 on the top, right? If we're square rooting something that is being squared, it's just that number, so the 5. But then we do have to remember to square the 8, so we get 64. Okay, and then the reciprocal of 3 we know is 1/3, right? Okay. So this, good, we're gonna use some of this math here shortly, so we'll get to that. But if you notice, first we're gonna talk reciprocals. If cosine of theta is 3/4, what's the secant of theta? What's the relationship between cosine and secant? They're reciprocal. So if we know what cosine is, well, how do we find secant? Flip it. So 4/3. All right, this one takes a little bit more work. We are using reciprocal identities. Notice that. So I am going to give you a hint. Cosine of x equals 4/5. We know a relationship about tangent that involves sine and cosine. So let's write that down first. We know that tangent of x is equal to sine of x over cosine of x.
Is that the quotient identities?
That's one of the quotient identities. Yep, good. Let's get sine by itself. So remember we decided that we could write this as sine is equal to tan of x times the cosine of x. So sine of x is tangent of x, which is 3/4, times cosine of x, which is 4/5. So we can divide out, I guess I should say. The 4's divide out, and we're just left with 3/5 for our sine value.
And you crossed the line.
I'm sorry?
You just crossed the line.
Yeah, crossed out the 4's. Right? These divide out. All right, last one here. We're asked to find tan of beta, tangent of beta. We know cosecant is the reciprocal of sine. And secant is the reciprocal of cosine. And we know tangent is sine over cosine. So let's plug in those values. Excuse me. All right, for tangent, we're doing sine, which is 7/25, over cosine, which is 24/25. If we were to do keep it, change it, flip it, there's our answer. That's what tangent of beta is going to be equal to. Yep, if you flip this, let me write it out. If we flip this, we're going to have 25/24. And when we multiply that, those divide out, and you're just left with the 7/24.
What do you do if it doesn't divide out? I'm just kind of like bad with.
Then you're going to multiply straight across, multiply your fractions. But on most of this type, they will divide out in some way, shape, or form. Good question, though. Okay, so one of my earlier classes was having a little trouble with this, so I'm going to remind you of two different ways to think through this. You may want to make a note about these. Either your all students take calculus. That might, for some of you, I think that is helpful. But let's also draw this. We did this also to help us. We have to think about in which quadrants sine values are positive and negative and that type of thing. So sine values are positive where? Which two quadrants? Yeah, 1 and 2. So that's up here. So that's up above, right? Because sine is the y values. What about cosine values? 1 and 4. Because it's x is being positive, so it's to the right. And what's about tangent? What's special about the tangent? 1 and 3. Remember, that's the weird one because it's diagonal. Good. Okay. I think that can be helpful if we're going to zip through these pretty quickly. So go back and look at this if you need to. And slow me down if you need me to, but I'm hoping we don't have to. All right. Sine is positive. What two quadrants?
1 and 2.
1 and 2, good. And cosine is negative in what two quadrants?
2 and 3, so it has to be 2.
2 and 3, so we know we're in quadrant 2. And it's asking, it's saying, what about the tangent value in quadrant 2? Is that going to be positive or negative? Negative. Tangent is negative in 2 and 4, right? Okay. All right, so the second one, cosecant is negative. That means sine is negative. So where is that?
It can't be in the first two.
Can't be in the first two, so it's got to be 3 or 4. And then cotangent is negative. That's here or here. So we are talking quadrant 4. And the cosine value in quadrant 4 is what? Positive. All right, how are we doing so far? Questions? We're kind of going through these quickly, but hopefully if you got to slow me down if you need me to. Tangent's positive. Where is that?
1 and 3.
1 and 3, good. And then secant and cosine is negative.
So 3.
2 and 3, right? So, oops, didn't mean to circle both of those, just 3. So we're in quadrant 3, and it's asking, in quadrant 3, what about the sine value? Negative, good. Okay. These next 3 problems are a little bit different. They're asking you to think about the interval here. If you need to look up here at the unit circle, then do. What quadrant is that saying? If we're talking about the interval from pi to 3 pi over 2, what quadrant is that?
3.
Yeah, that's quadrant 3. There you go. And the sine value in quadrant 3 is what? Negative. Okay, pi over 2 to pi. What quadrant is that? 2, yes. And the tangent value in quadrant 2 is negative. And then last one, 3 pi over 2 to 2 pi. Yep, good. That's quadrant 4. And that's cosecant, which is equivalent to sine. So what sign is that? Positive or negative? Negative. Okay. Thank you. I had all of my other classes, they were like, surely there has to be another one that's positive. So they weren't even thinking about the answer, and they insisted it had to be positive, and it is not. Okay. Good. Questions on that? I know we're going through this stuff pretty quickly. We got 2 more problems to work through. These are a little more involved, so. All right. Up until now, if I gave you a problem like this, what you would do to solve is you would draw a triangle on the coordinate plane, use your Pythagorean theorem, and solve using like SOHCAHTOA. But now we are going to use Pythagorean identities, and yes, I'm going to expect you to show me the work using Pythagorean identities. If you're drawing triangles, I'm not giving you credit. You need to understand that. I want to see that you're using these and thinking through how you solve these. And it will, I promise you, on down the road, you're going to want the practice with doing this method as well, based on some other stuff we're going to be doing later. Okay, so think about what this is saying. We're given our cotangent value. That means we also know our tangent value. And then we're told quadrant. So what quadrant are we talking about? Yep, we're in quadrant 3, good. And we're supposed to find all of the trig functions. So actually, I'm going to scoot over here. Let's go ahead and put in a sine of theta equals. Let's write all of this out. All right, I just remembered seniors, I've got something I need to get to you that we are going to be working on Monday that we'll have to play catch up with you guys on your return, but okay. I'm sorry. Okay, cotangent is 3 over 4. So we can go ahead and label that, and that means we can also put in our tangent, which is 4/3. I want to think about sines, though. If we're in quadrant 3, what do we know about the sines for these other trig functions? They should all be negative, right? So I'm going to go ahead and put those in now. For me, I tend to forget about dealing with my positive and negative signs, so if I can do that, I want to, yes.
How did we know it's quadrant 3 again?
It was saying that from this right here, from pi to 3 pi over 2.
Yeah.
So if you look in unit circle from pi to 3 pi over 2, that's saying that's the interval of quadrant 3. Does that help?
Yeah.
Okay. All right. So we need to find sine, cosine, and its reciprocals. We want to use Pythagorean identities. And we're given something about cotangent. So let's think about our identities. No, you can't quite do that. You're on the right track, but not quite. Be careful. Nicholson, what's your identity say?
1 plus cotangent squared x
Equals cosecant squared x. There we go. So we can plug in what we are given for this value of what cotangent is. So we can say 1 plus 3/4 squared is equal to cosecant squared x. And we're going to do the math there. Jude?
Can we just use the quotient identity and just like find the sine and cosine and just look at it?
Hold that thought. We can talk about that for this next one, but not yet.
Okay.
So we'll get there. Okay, so 1 plus, if we square that, we get 9/16 equals cosecant squared x. I'm going to rewrite this, let me do this here. I'm going to rewrite that 1 as 16/16 plus that 9/16. So 25/16 equals cosecant squared x. So if we take the square root of both sides, we should be considering whether it's positive or negative, but the good news is we've already decided on that, right? We put those signs in there already. So we just figured out that our cosecant value is 5/4, and it's negative. And so the sine value is negative 4/5. And now we just have to figure out our cosine and our secant. Here's where you can use your quotient identities, Jude, if you would like.
But couldn't you use it for like the stars since you had the tangent?
Yeah, you don't have quite enough there for that because you wouldn't get your R. Okay. So we could use quotient identities at this point because there's a relationship with tangent being sine over cosine. You could use quotient identities, and I would be okay with that as long as you're showing me Pythagorean identity at least once. But I want to show you and give you some practice using these Pythagorean identities. So I want to use Andrew's identity and use that sine squared x plus cosine squared x equals 1 to get our cosine, because we have our sine and we need our cosine. So I want to think sine squared x plus cosine squared x equals 1. So I'm going to plug in this negative 4/5, and I'm squaring that. So 16/25. I'm going to rewrite that as 25/25. Because if I do 25 minus 16, I get 9/25. And so my cosine value, I'm taking the square root. So the square root of 9 is 3, square root of 25 is 5. So I get my 3/5 for my cosine, and then my secant is 5/3.
That was about to look good.
Mm-hmm. Now, guys, I decided to use Andrew's identity, the sine squared x plus cosine squared x equals 1. But we also could have used Drew's identity, the 1 plus tangent squared x equals secant squared x, because we had tangent squared and we could have figured out secant and then gotten our cosine. So just realize, in some instances, not always, but in some instances, there are multiple identities that you could use to come up with your answers. Okay? All right, questions, comments? Yes, Landon.
Show all our work.
I'm gonna wanna see, yeah, I'm gonna want. Right, at that point, you've gotta show me some type of math involved besides just saying this is a triple and I know that other value, as long as you're doing that other work. It could be quotient identities or the Pythagorean identities after you've done this first one. But that's a good point too. All right, let's try this next one. We're gonna be doing similar process, so I'm gonna go ahead and. The cosine is negative, yes.
Why?
Because we are in quadrant 3. So sine theta. So I'm going to write this out first just to get this out of the way. Okay, and then let's think about sines. Okay, we are from pi over 2 to pi. So what quadrant is that? Careful, pi over 2 to pi, yeah, so we're in quadrant 2, good. So in quadrant 2, we know sine and its reciprocal are positive. That means those are negative. So I'm setting my signs already, just so I don't even have to think about that later. Okay, and I'm given something about tangent. So I'm thinking I want to use Drew's identity to begin with. Drew, what does your identity say?
It's 1 plus tan squared x equals secant squared x.
There we go, 1 plus tan squared x equals c. You've got it. Nice work. Okay. So let's plug in 1 plus negative 1/2 squared equals, so 1 plus 1/4. Let's rewrite that 1. I think you realize now why we were doing some of those basic math problems to begin with, just to kind of help with some of this. Okay, so when we take the square root here, we get the square root of 5 over 2. And thankfully, we already have our signs set, so we know, oh, yeah, we can, okay. So that's our secant value. We can flip this, so we get negative 2 over root 5. So when we rationalize that, we get that. But we are also given tan is negative 1/2, and our cotangent is negative 2 over 1. Okay? All right. I will tell you, at this point, in my opinion, what would probably be fastest and easiest is to use Nicholson's identity and do 1 plus cotangent squared x equals cosecant squared x. However, I am going to show you, and I know this seems like a lot of extra work, but I want you to see an example where you have to square with the radical in it, because a lot of people have trouble with that. And in some instances, you cannot avoid it. If you can avoid it, great. But there are going to be other times where you cannot avoid and you have to square, and it has a radical in it. And so I want you to see an example of that. So let's go, we're going to do Andrew's identity again. So we're going to use the sine squared x plus cosine squared x equals 1. And that's squared. So I kind of want to highlight here for you to help. Okay, so we get sine squared x plus. That -2 gets squared, so that gives us 4 times the square root of 5 squared gives us a 5 that we're multiplying by, over, then we do have to square the 5 squared, so we get 25. So take a look at that again. Think about it kind of as those each individual parts and square it. So square the -2, square the square root of 5, square the 5, right? So that gives us sine squared x plus 20 over 25 equals 25 over 25. There you go. So sine squared x is, when we subtract, we get 5 over 25. So our sine is positive root 5 over 5.
Wait, I wouldn't be. Oh, I didn't see that. Okay.
Okay, and then if we flip this, we get 5 over root 5, which then we have to rationalize. So we end up with 5 root 5 over 5, which just gives us root 5. Okay.